engineering applications. Information about the phase boundaries is important for storage of substances in a two-phase state like a bottle of gas. The pressure is the container is the saturation pressure for the prevailing temperature, so an estimate of the maximum temperature the system will be subject to gives the maximum pressure for which the container must be dimensioned. These two figures shows the example of a storage of substances applications. The storage tanks, a stainless steel tank, and the top of a aerosol can. These container are the devices for the storage substances in high pressure, and also the example for the tanker transport liquid liquefied natural gas as the container. The next example is related to the high pressure or the application of thermodynamics is in a refrigerator. A compressor pushes the refrigerant through the system and this determines the highest flow pressure. The harder the compressor is driven, the higher the pressure becomes. When the refrigerant condenses, the temperature is determined by the saturation temperature for that pressure, so the system must be designed to hold the temperature and pressure within a desirable range. This figure shows the compressor and the condenser of the refrigerator as an application to thermodynamics. In this chapter, the compressor and condenser of the refrigerator. The effect of expansion, contraction of the matter with temperature is important in many different situations. Two of these are shown in this picture. Thermal extraction joint, applications, a bridge. The railroad tracks have a small gap to allow the expansion. It leads to the familiar clanked sound for the train wheel when they roll over the gap. A bridge may have a finger joint that provides a continuous support surface for the automobile's tires so that they do not bump as the train does. When air expands at constant pressure, it occupies a large volume. Thus, the density is smaller. This is how a hot balloon can lift a gondola and people with a total mass equal to the differences in air mass between the hot and inside the balloon and the surrounding cooler air. This effect is called the buoyancy, described in the fluid mechanics. Although we have an example also here. A balloon, hot air balloon, the buoyancy forces to the low dense air goes to the vertical motion.